grade 11s, and welcome to today's lesson. We've moved on from physics and we're starting with chemistry. And what we're going to start with today is molecular shapes. Let's get going. The first thing we're going to do, terminology. I think you're used to that by now, so we're going to have a look at the terminology I've got from you. Then we'll delve into the fun and the cool stuff that is molecular shapes. So let's go. First thing, terminology. I'm going to read the terms to you, and then I'm going to give you 3 minutes. I want you to just note down with your partner or on your own what you think these terms mean, and then we'll come back and do them together. But let me read them through for you, and then I'll let you go. So the first one, Lewis diagram. The second term, valence electrons. The third one, lone pairs of electrons. The fourth one, a chemical bond, and the fifth one, electronegativity. So those should be 5 terminologies that you know already. So let's see what you know. I'm going to give you 3 minutes to write down the definitions or how you understand those 5 terms. 3 minutes starting now. Okay, everybody, hopefully you've managed to get some definition or some understanding of what these terms mean down on paper. Let's go through them together. Lewis diagram. So what is a Lewis diagram? It is a structural representation of a molecule where dots are used to show electron position around the atoms, and lines or dot pairs represent covalent bonds between atoms. So a lot of words, but in case you don't remember what a Lewis diagram is, I'll draw one for you. I'll draw the Lewis diagram for sodium. So remember, you write the symbol, and then you just draw a single dot to indicate how many valence electrons are associated with sodium. So if you haven't got it down, remember it is all about the valence electrons. Right, so the next question is, or the next terminology is, what is a valence electron? And here, we should all know by now, hopefully, that it is the electron in the outer shell of an atom. And this is the one that can be lost to or shared with another atom to form a molecule. So remember, in an ionic bond, your valence electron valence electron is the electron that's going to move from one atom to another. And if it's a covalent bond, it's the electron that's going to share its space with a valence electron from another atom. Okay, so those are the electrons that are responsible for our bonding. Okay, right, hopefully everybody's tracking. Next terminology. Oh, lone pair of electrons. We see this terminology every now and again, but we haven't really used it much. We'll be using it a lot today. Lone pairs of electrons, it's a pair of electrons occupying an orbital in an atom or a molecule and not directly involved in bonding. So let me draw a decent one. An example of what we mean here. I'm going to use oxygen. Oxygen has got 6 valence electrons. I'm going to draw the Lewis structure for oxygen. It's got 6 valence electrons. And these 2 pairs here are our lone pairs. Okay, so they belong to the same atom and they're a pair, so it's 2 electrons, they're not sharing with anybody else. The individual electrons over here, those are known as our bonding electrons, because those are the ones that we're going to move around, or we're going to allow them to share space to form a bond. Okay? The next one is a chemical bond. So what is a chemical bond? It's the net electrostatic force that 2 atoms sharing electrons exert on each other. I want you to please make note of this phrase here, net electrostatic force. Electrostatic forces, or an electrostatic force, is the positive and the negative that we have in substances. So we say that protons have got a positive charge and electrons have got a negative charge, and that opposites attract. We say the positives and the negatives attract. Now the scientific word for that, or the scientific terminology for that, is electrostatic. It comes from static electricity, where your positives and your negatives attract. Same thing in bonds. The positives, or the protons, will attract the electrons, and the electrons will attract the protons. So we say it is an electrostatic force of attraction. Just so that you don't get all worked up and think, oh my goodness, it's a whole new terminology. It's a really, really fancy way of saying the positives are attracting the negatives. Okay, so hopefully nobody's panicking now. It just means that your opposites, your protons, are attracting your electrons are attracting your protons. Next term. Electronegativity. This is a measure of the tendency of an atom to attract a bonding pair of electrons. Okay? Please make sure that you do not confuse this with electron affinity. So electronegativity, there has to be a bond and it has to be a shared pair of electrons. Okay? So one from one atom and another electron from a second atom, and where those 2 are shared, when an atom wants to attract that shared pair, we call the measure of the attraction. So how much it attracts them, we call that the electronegativity. Okay, so I'm going to write here, under bonding, I'm going to add in that it's a shared pair, just so that you can make sure that you understand what I mean by bonding pair. Okay, so it's a shared pair of electrons. Okay, so hopefully everybody's okay with that. Let's go on to what we're going to do with this. We are going on to a molecular shape theory called VSEPR. And the VSEPR, sometimes people call it VESPR. but VSEPR stands for Valence Shell Electron Pair Repulsion Model. What does that mean? It means the following. Why am I looking at Lewis diagrams? Because I want to look at the valence electrons. What are the electrons that are involved in bonding? The valence electrons. So that means that the valence electrons and the way that they interact with each other and the way that they're arranged around atoms affects how the molecule looks. In other words, it can change the shape of a molecule. And I know some of you are thinking, well, I didn't even know molecules had shapes. I just know that they've got letters and they've got atoms and they've got protons and electrons. They actually do have shapes, and different shapes mean that there are different physical properties. It can change the boiling points. It can change the melting point. It can determine if it's a gas at room temperature or if it's a liquid at room temperature. So shape has a really, really important role to play in chemistry. In fact, it even affects how atoms and molecules react. Okay, so that's why we need to do this. We need to understand what the shape means in terms of the behavior of the substance. High boiling point, low boiling point. It's going to react easily, it's not going to react so easily. It's a liquid, it's a solid, it's a gas. Okay, so just keep in the back of your mind as we go through this, that is why we are doing this section, so that it will influence and it will help us to understand what we're going on to in the next lesson. Okay, so let's have a look in more detail what this means. It is a model for predicting the shapes of molecules in which structural electron pairs are arranged around each atom to maximize the angles between them. I will come back to what we mean about structural electron pairs. The second thing about VSEPR is that it assumes that each atom in a molecule will achieve a geometry that minimizes the repulsion between electrons in the valence shell of that atom. Wow, that's a lot of terminology to try and get into your head. So quickly, let me summarize for you. The structural electron pairs, those are our lone pairs and our shared pairs or our bonding pairs. How do they interact? That's the first point. The second point is because they are negatives, they're electrons, and there's pairs of electrons. What do we know about like charges? We know that like charges like to repel each other and push each other away. So the second part of this definition or of this explanation talks about achieving a balance within the molecule where they are as far away, the electron pairs are as far away from each other as possible without physically leaving the atom. So they're in a bit of a tension. They're not too close and not too far away from each other. They're sort of in between so that they can be as far away as possible without leaving. And that there will determine the shape of our molecule. Okay, so it's the fact that it's bonding pairs and lone pairs, and then how they are arranged next to each other, trying to get as far away from as possible without actually leaving each other. Right. So I'm going to give you an idea of what the basic shapes are. So we've got 5 basic shapes. We've got linear, we've got trigonal planar, we've got tetrahedral, we've got trigonal bipyramidal, and we've got octahedral. Okay? So it looks like a lot, and if you look at these pictures, you think, oh my goodness, I don't know where to start, I don't know what to do. Don't worry, we're going to go through this slowly. We'll go through it together to make sure you know what's going on. The most important thing here with this, the 5 basic shapes. There is a central atom. You'll have a look that there's a central atom, and the important thing about that is that there are no lone pairs of electrons on the central atom. So if you're making notes, I want you to make sure that you write down that there are no lone pairs of electrons. I'm going to use E with a negative to represent electrons. There's no lone pairs of electrons on the central atom. All right? So that is important when we talk about the 5 basic shapes. So again, let's just have a look at them, because what I want to do is I want to go for a break. I need you to have your brains rested, we've done a lot of terminology, and then we're going to come back and look at the pictures. But before we go to break, let's just have one last look at the pictures, then I'll let you go and you can breathe and come back. So first one, linear, have a look. There's our shape, it's in a straight line. Our trigonal planar, it's in that shape. Okay. Our tetrahedral, it comes down, it goes along, it goes out towards the back and out towards the side. Our trigonal bipyramidal, it goes up from the central atom, down from the central atom, and then here it's got a planar shape going around the middle. And lastly, our octahedral, it looks like a combination of tetrahedral and pyramidal. So to try and figure out these different things, we're going to have to spend some time doing it. So going to give you a break. We're going to go to some adverts. You do what you need to do. Just sort of breathe a little bit, give your mind a rest. I'll see you in a short while.